So now we're going to head on to the one that is going to be probably the most complicated of these problems. And we're going to need a lot of space to do this work. So I'm going to go right down here to the bottom. And we are going to start by doing some stuff. So the first thing that I would recommend is let's kind of get this square root thing, this fifth root, to be an exponent. Okay? So we're going to start with x minus 3 to the fourth, x squared plus 1 all over 2x plus 5 to the third. And I'm going to change the exponent to the 1/5 power. Okay? So now, here's why logarithmic differentiation is going to help us out. So watch as we kind of go through. The only thing I'm going to use are those logarithm rules, like where you multiply, you can change it to addition, where you divide, you can change it to subtraction, and things like that. So we need to take the natural log of both sides. So please remember, you do have to take the natural log of y. But then we're going to take the natural log of this whole thing. So this is x to the fourth, just making sure, x squared plus 1 all over 2x plus 5 to the third, and it's to the 1/5. So what does that allow us to do? Okay, that now allows us to take the 1/5 out to the front. So we're going to just drag a lot of stuff along. So I now have 1/5 natural log of x minus 3 to the fourth, x squared plus 1, and then 2x plus 5 to the third, and I can pull that 1/5 all out to the front. Okay? Now I can start doing a couple other things. Because it's the natural log and I have something that's being divided, that means that I can subtract. So I'm going to get 1/5, and I now know I can subtract these two things. So I'm going to have the natural log of x minus 3 to the fourth, and I have x squared plus 1, okay, minus the natural log of 2x plus 5 to the third. Okay, so now I can change that all to subtraction. And now I got a couple of other things. So I'm going to do all of these in one fell swoop. So I still have the natural log of y over here. And I still have the 1/5. But now we're going to do a bunch of work with this natural log stuff on the inside. So first of all, we're going to just go with this. Because it's multiplication, I can change that to addition. So it's going to be the natural log of x minus 3 to the fourth plus the natural log of x squared plus 1. So what you're starting to see now is it's starting to get to smaller chunks that we can manage. And we still have minus this part. But the first thing I'm going to do is I am going to move the 3 out to the front because you always can move the exponent out there. So I'm just going to change it to 3 natural log of 2x plus 5. Okay? So this is our final expression. The only thing I'm going to do is, so I don't have to rewrite this whole thing, I'm just going to say, notice this 4 that's right here. I can move that out to the front. So I'm just going to cross the 4 out, and I'm going to put the 4 to the front. Because remember, we're allowed to do that with these exponents. So now, this is what we have. Now we have to take the derivative. Notice, I have not done any derivation. I have only used the logarithm rules to get this to something that are smaller, more manageable chunks. Okay? So here's what we're going to do. We're going to take the derivative of this part, and we're going to take it piece by piece. And I'm going to have to do some work off to the side. So first of all, it's going to be 1 over y times y prime. If you take the derivative of natural log of y, it's 1 over y times y prime. Now, I still have the 1/5 out here, so we're just going to take that, and we're just going to leave it there for now. Okay? And now we need to take the derivative of each of these pieces. So you will notice that each chunk is most likely going to be a chain rule. So we're going to have to use the chain rule for all of these. So the first thing is I'm going to take this first piece and I'm going to move over here to the side and I'm going to do my chain rule work. So notice I have a constant out front, so I'm just going to leave that there. But I'm going to go through and I'm going to put my outside and my inside. My outside is the natural log of x, and my inside is x minus 3. So this is going to be 1 over x, and the derivative of this is just 1. Okay, so that makes that kind of easy for us. It's just going to be 1 over x minus 3. So remember, we still have the 4, but it's times 1 over x minus 3. That is the derivative of that first piece. Okay? Now, let's go to the next chunk. You should notice again, this is going to be the chain rule. So I'm going to go off to the side here, and I'm going to do my chain rule stuff for this piece. So it's going to be natural log of x, and then notice the inside is x squared plus 1. So still, the derivative is 1 over x, and the derivative for this one is 2x. So when I put all the pieces together, it's going to be this 1 over x squared plus 1, and then times 2x. So I'm going to put that over here. So it's going to be 1 over x squared plus 1 times 2x. So I'm just going to write it all as one thing. And there is the derivative of that piece. So now, let's move to this chunk. You should also notice that this now is the chain rule with a constant out front. So I'm going to go outside and inside. Again, my outside is the natural log of x. My inside is 2x plus 5. So again, it's going to be 1 over x, and then the derivative of this part is 2. So using our chain rule, we still have the constant out front, so it's going to be minus 3 times, it's going to be 1 over 2x plus 5 times 2. So I'm just going to write that in as 2 over 2x plus 5. Okay? And there we go. We have now taken the derivative of each of those parts. Okay? Now, I can't ask you any questions, but this is kind of where we're at. So now what we're going to do is let's kind of get rid of that 1/5. And so we have just one sort of expression. So we're going to actually just distribute the 1/5 to each one of these pieces. So here's what we're going to get, because we're going to have to move the y over to the other side. So we still have 1 over y times y prime. And now I'm just going to distribute this. So this is going to become, if I combine this, it's going to be 4/5 times 1 over x to the third. So it's going to be 4 times 5 over x minus 3. Remember, you're just multiplying the numerators together and multiplying the denominators. So this is going to be 1/5 times this. So it's going to be 1/5 times 2x. So it's going to be 2x still on the top. And then it's going to be 5 times whatever's on the bottom. And then we're going to multiply 1/5 times this. But we also have 3 times 2. So it's going to be 1 times 3 times 2. So that's going to be 6. And then we're going to have 5 times whatever's on the bottom, which is going to be 2x plus 5. Okay? So this is now our final sort of expression. This is simplifying all of that natural log stuff. So now we have to go back to what implicit differentiation always says. Okay? If you're going to do implicit differentiation, we now have to get y prime by itself. So that means we need to multiply by y. That means I need to multiply this whole side by y. Okay? So when these cancel out, we're left with just y prime. So this is our final answer for the logarithmic differentiation problem. But is it? Okay? it actually still is not the final answer. Because remember in the beginning instructions, it says only in terms of x. So guess what you have to do? Because you have this y here, we need to replace it with what y equaled in the very beginning. So you have to physically put this back in to your final answer. So instead of having this y here, and I'm just going to so I don't have to rewrite all that, I'm just going to put the parentheses and I'm going to put x minus 3 to the 4th times x squared plus 1 over 2x plus 5 to the 3rd, all to the 1/5. This is your final derivative answer. Okay, this is it. So this is what logarithmic differentiation looks like. It is really a long process. Okay, it takes a lot of time, and you really just have to systematically work your way through it. But please remember a couple of key things. Number one, only use it when you have x in the exponents. It allows you to take that exponent out, or when you have super complicated rational functions. It does allow you to then take it and make it into smaller chunks. If you take a look here, notice this big complicated fraction slowly became small chunks that we could just do quick chain rules on, okay? And then we just have to put it all together. Also, just remember when you do this, your final answers tend to be really complex with lots of different pieces and parts. So that's logarithmic differentiation. I hope this helps you, and I hope this helps you get your homework completed. So I will see you again at some other time.